Welcome to Making Stuff with Chris Dayhut and our segment titled This Maker's Tools. For today's tool, we are looking at the Digital Readout, or DRO, as it is commonly called. These are used on machine tools, and this system tracks the position of the tool and table accurately and continuously. It replaces a process of reading marks on a hand wheel and counting the revolutions of that hand wheel to determine how far you've moved. That process, as you can imagine, has great potential for a lot of human errors. There are two primary components in the system: the display, which performs the reading of the scales and displays the results, and then the scales, which are linear encoders with a very fine resolution. The unit that I'll be showing you in a little bit here has a resolution of 0.0001 inches. Very fine resolution, and they help tremendously with making accurate components. The simplest way of describing the scale is to use a scale such as this, a basic ruler, if you will. Here you can easily see accurate markings on this, which are spaced 0.0156 inches apart, which I think is about 0.4 millimeters. Obviously, this is large enough that we can actually see the markings. Now imagine if those markings are spaced 0.0001 apart, and you use a very tiny sensor to read those marks. That on-off signal, looking at the mark or the space between the mark, is sent back to the digital display unit, where it is counted and processed depending on the type of input signal, then output to the actual display that you see as the numbers change. These units are very accurate, even in the hobbyist level units such as this one. The resolution on this one, as mentioned, is 0.0001 inches, or, in the metric world, 0.0025 millimeters. The display unit allows you to preset a value, in other words, set it to some value where it's currently at, or just simply set it to 0. Then as you move the axes, you will see that it constantly tracks the movement and displays the updated position. No math, no need to remember revolutions of the hand wheel, just simply read the position on the display. Just so that you have an appreciation of what these things offer, let me demonstrate it for you real quick. From this location on the workpiece, you can see I've got a pointer pointing to a location. I need to move the tool 1.375 inches in the Y- direction and 2.4375 inches in the X+ direction. This is how fast and easy it is using the DRO. I move both hand wheels at the same time to get over to the location roughly. Then I sneak up on the final destination and dial it in perfectly at both of the correct coordinates. Now let's reset this, and I'll demonstrate the old-fashioned way. We start out first by setting the counter or the index mark to 0 on the axes we're working with, in this case Y. Now I will start rotating the hand wheel. It will move 0.1 inches for every rotation. I keep rotating. In this case, I need to move 1.3 inches, so I move 13 revolutions, counting it each time, and then moving up for the final amount of 75. So we end up at 1.375. For the x-axis, it's the same thing. I reset the counter to 0. Or I should say the dial back at 0. I start rotating the handle. This time I've got to rotate it 34 revolutions. You can imagine how easy it is to lose count along the way, especially when your shopmate comes along and starts distracting you with some random question. And as you can see, as we get to the end there, I slow down, carefully come up on the final numbers, and we are in position. As you can imagine, a lot of errors were made in this throughout history. You also can't move both axes at the same time using the hand wheels, so the process ultimately can be much slower as well. For many years, the DRO was considered a luxury item on a machine, but thankfully they have gotten less expensive and much more reliable and accurate over time, and now it is rare to see a machine without a DRO in a real machine shop. These are now affordable for the home machinist as well. This particular unit I have here, all-inclusive, meaning the scales and the digital readout unit, as well as the cables, was less than $200 on AliExpress, and that was about 10 years ago. Of course, I had to install it, but let's face it, if you're working on an industrial type machine such as this milling machine or a lathe or a grinder, you should have the skills to be able to install one of these. Digital readouts are used on different types of machines, but commonly you will see them on milling machines such as I'm demonstrating here, lathes, and cylindrical or surface grinders. Applications outside of industrial use are very limited, but without a doubt, the integration of these systems has revolutionized machining on manual machine tools, both in industry and now in the home workshops. With that, I think we can wrap up this video. I hope that you enjoyed it and you found it informative. If so, I would greatly appreciate it if you could go through and give me a like, subscribe, or drop a comment down below. Tell us what you thought of it, what you'd like to know more. This is a complicated system. Maybe you got some questions you want to ask. Feel free to do so. Thanks again for watching, and I look forward to seeing you in another episode.
And he made her swear she'll break out.